Hello class and welcome to our next video lesson. Today we'll be looking at section 2.2 and sections 2.3. Section 2.2 is called the distributive property. It is found on page 73. And the next section we'll be looking at is simplifying variable expressions. And it is found on page 78. Please follow along and I hope you enjoy the ride. Bwahaha. All right, so looking at section 2.2, example 1, this is kind of a no duh, but we just need to make this statement with the distributive property because this is a very important part. When you have a number touching a parenthesis, you're supposed to multiply. So 3 times 5 is how we read this, okay? So we'd say 3 times that 5 right there, and we would end up with 15. Simple enough. All right, let's look at the next example. Here we have two identical problems. So make sure you copy both of these down. Now I'm going to work the first one out, for lack of a better word, the traditional way, using order of operations. So according to this, we would say 2, parenthesis, 10 plus 4 is 14, because we do it inside parentheses first, and then 2 times 14 would be 28. Now, the distributive property, and we're showing it first with numbers because we need to see how it affects variables in just a moment. But the distributive property says I'm allowed to actually multiply first, even though there's parentheses here, so long as I multiply everything inside the parenthesis by the number outside. So we take this and we distribute it to both of these. It's helpful to draw your arrows like this to say I'm multiplying everything in here by 2. So I end up with 20 plus 8. Well, 20 plus 8 is 28. You get the same answer. You're allowed to kind of tweak the order of operations a little bit right here using the distributive property, so long as you make sure to multiply both numbers by the outside number, okay? And this is true if I had 3 numbers or 5 numbers. I multiply each number inside the parenthesis by this number right here. All right. Let's take a look this time with variables and with throwing in some negative numbers, all right? So here we have, for our first example, we have 2 parenthesis x plus 5, okay? So let's see how we work this problem. So here we have 2 times x and 2 times 5. Well, 2 times x, I don't know what that is. I don't know what x is. So what you do is you just write down 2x, because 2x, we know that this tells us that this is 2 times x. Since I don't know what x is, I just write it down. I say 2 times x, 2 times x. That's all, okay? It's easy. Plus 2 times 5. I can do 2 times 5. That's 10, okay? Over here, I wanted to show you an example of where they put the variable at the back. It doesn't change anything. You're still going to multiply it by each of the terms in here. So 4 times x. 4x minus 4 times 3. 12. 4x minus 12. Over here, you need to pay close attention. We have a negative 2. So I'm going to multiply this negative 2 by everything in here. So if we have negative 2x minus negative 2 times 7 is negative 14. If we're told to simplify, that's what most of this is going to tell us to do, tells us to simplify, we need to fix this. It would become negative 2x plus 14. Remember, add the opposite. This changes to addition. This becomes positive. So that is the simplified answer. So your answer for C is right here. Your answer for B is right here. And your answer for A is right there. You can't do anything else. You don't find x equals. You don't find just one number, it's an expression, okay? So this is an example where simplifying, you can't simplify it anymore, okay? It just stays like this. I cannot add 2x plus 10. I don't know what x is, so you have to leave it like that. That is the answer. If you do anything else to it, you will get the wrong answer. So stop before you get too far and you mess it all up, okay? It's done. Now we need to look at section 2.3, okay? Section 2.3 has something we need to look at first. This should go in your notes. If you need to copy this down, that's fine. I recommend you listen to what I'm saying first, then pause the video and copy this down. This is an expression. We have 3x plus 5x plus 7y plus 10. Okay. Each of these that have the blue above them, they're known as a term. T-E-R-M, term. So these are terms. There are 4 terms right here. The red right here is saying that the 3x and 5x are like terms. You might want to make a note of this or just pay attention. You can maybe make a note of it later, but like terms can be added together, okay? The 10 right here is known as a constant. It's a constant because it doesn't change. It stays a 10 because there's no variable by it. You see these? They all have variables by it. These are not constants. Constant, no letter by it. The numbers in front of a variable are known as coefficients. So 3, 5, and 7 are coefficients, okay? Let's take a look at what this now looks like. We're going to explore this idea of like terms. So let's look at this example. Similar to the one we have above, we have 2x plus 3x plus 4y minus 28. I already told you that because both of these have x's, just like the example above, they're like terms. You can add them together. So you end up with 2 plus 3 gets you 5x. You don't add necessarily x's. You just say, I got 2 x's, I have 3 x's, I add them together, I have 5 x's. Plus 4y minus 28. So if we were told to simplify this, this is what you would do. You can't go any further. This is not, there's no more like terms. After you get done combining the like terms, you're done. So just a reminder, the numbers in front, coefficients, this number with no variable is a constant. Each of these is considered terms. If they have the same variables, they're considered like terms. So there you go. And this is our answer. We are done. The main thing is to remember not to go too far. Let's turn the page over and look at a few more examples. All right, so in example 5, we have 4x plus 3y plus negative 5 plus y. So our like terms are this. It's the 4x and the negative 5x. So what is 4 plus negative 5? Well, it's negative 1. So you can put negative 1x plus, what is 3y plus y? Well, the students mess this up because they see y and they think, oh, well, how do you add that? Well, how many y's are right here? You don't see a number, but how many y's are right there? 1. So I have 3y plus 1y. It is equal to 4 y's, and you're done. Okay? So negative 1x plus 4y. Next example. I would like for y'all to pause the video and try to work out these 3, and then click play to see if you got the right answer. So for this first one, we say 3x minus x. Well, that's 1x. So that would be 2x, 3 minus 1. Over here I have negative 3y minus 4y. Well, if I use the, add the opposite, I have negative 3y plus negative 4y. That makes negative 7y as my answer, okay? That's the answer there. Forgot to box this in. Over here, we add the opposite again. So 5x plus positive 3x, 8x, okay? believe this is the last example. Using the distributive property and using what you've already learned about adding like terms, I want you to attempt to see if you can solve this by yourself. Pause the video, take a look at it, and see if you can solve it yourselves. And then click play and watch what I do. What you're going to have to do is you're going to have to distribute first. Okay? So we copy back it down. We say I have 4x plus, well, I say 2 times 6 is 12, plus 2 times x is 2x, okay? So now I have 4x plus 12 plus 2x. I add my like terms, my 4x and my 2x. I end up with 6x plus 12. And I want you to know something. The order is kind of important. It doesn't make your answer to say wrong. It's that most math people will write down the letters, like they'll put the coefficient in the front and then they'll put the variable, and the constant always brings up the rear. The constant is like the caboose of a train, okay? And they like to list their terms in alphabetical order, meaning that if I had a bunch of X's and Y's and Z's, I would go X, Y, Z. If I had A's, B's, and C's, I would go A, B, C, okay? That's the order they like to put them in if they can. It's not super important to know right now. You'll get more practice later. Just wanted you to know. So hopefully you've done well, and if you have any questions, look back over this, write them down, and be prepared to discuss this in class because these concepts can be difficult. See you in class.